skipping the do now. We have to go over some basic definitions first. I can get there. Here we go. Inscribed and circumscribed polygons. A polygon is inscribed in a circle if all of its vertices lie on the circle. A polygon is circumscribed about a circle if each of its sides is tangent to the circle. All right, so if you notice my first diagram, do you see how each of the vertices of the triangle are on the rim of the circle? This means the triangle is inscribed in the circle. If I were to draw my diagram like this, would my triangle be inscribed in the circle? No, that would just be a triangle inside of a circle, right? Inscribed in means all its vertices have to be on the rims. So the triangle is inscribed in the circle. The circle is circumscribed about the triangle. Right? So here, this time, the circle's inscribed in the polygon. What is this, a pentagon? 1, 2, 3, 4, 5, yeah. So here, the circle's inscribed in the pentagon, but the pentagon is circumscribed about the polygon. All right, so those are our two new vocabs, words. All right, inscribed, circumscribed about. We don't need to know any of this definition. We don't need to know circumcenter. All right, let's just practice. In the diagram to the right, the pentagon is what? Inscribed or circumscribed about the pentagon in reference to the circle. So is the pentagon inscribed in the circle, or is the pentagon circumscribed about the circle? Circumscribed about. And what about the circle in reference to the pentagon? Is the circle inscribed in the pentagon, or is the pentagon circumscribed about the, or is the circle circumscribed about the pentagon? Well, inscribed. The circle is inscribed in the pentagon. All right, we don't need to know this. All right, theorem, I'm not going to prove it, but I will tell you so you understand how to do it in algebra problems. If a quadrilateral is inscribed in a circle, its opposite angles are supplements. Right? What does that mean? So here, do you see quadrilateral four-sided figure? I have a four-sided figure inscribed in a circle. The angles across from each other will add up to 180. So angle A and angle C add up to 180. Angle B and angle D add up to 180. Anytime you have a quadrilateral inscribed in a circle, the opposite angles are sup.
I didn't get that. Could you try again?
All right, this is a big one. If a parallelogram is inscribed in a circle, it must be a rectangle. So if we have a quadrilateral inscribed in a circle, we know the opposite angles are supplements. But now I'm going to elevate this. I'm going to say, well, if I have a quadrilateral, not just any quadrilateral, if I have a parallelogram inscribed in a circle, then that parallelogram must be a rectangle. Let's talk about why. If I just have a regular quadrilateral inscribed in a circle, we know from the previous theorem the opposite angles add up to 180, right? Opposite angles are sum. So that means big angle A and big angle C add up to 180, and big angle B and big angle D add up to 180. But now they're saying, well, if this quadrilateral is not just any quadrilateral, if it's a parallelogram, what do we know about any opposite angles in a parallelogram? They have to be what? Opposite angles, Jeff. Congruent. So if A and C have to be sup and congruent, what is the only number they can be? Your sup and congruent. 90. If B and D have to be sup and congruent, what's the only number they can be? 90. If I have four 90-degree angles in a quadrilateral, it is immediately a rectangle. We don't have enough to say it's a square, but we do have enough to say it's a rectangle. Who are you talking to, Kaylee? Oh, you were just, she wasn't responding to you. Don't worry about anything like this. Take this out. All right, these are the big problems. All right, these are the ones we need to know. It says the radius of the circle is 8. Find the perimeter of the equilateral triangle. All right, so whenever you have these inscribed polygon algebra problems, you're going to do this the same way, and you're definitely going to see these. You're definitely going to see them on your quiz. So what you're going to do is you're going to draw radii, but there's a bunch of places to draw radii, right? Isn't this a radius? All right, the place you're going to draw the radii is to the corners of the polygon. What does that mean? I'm going to draw a radius from the center to this corner vertex, from the center to this vertex, and from the center to this vertex. So you draw the radii to the corners of the polygon, or the vertices of the polygon. All right, now we know all these radii. It says the radius of a circle is 8. So we know this is 8, this is 8, this is 8. Now, what kind of triangle were we dealing with? It says find the perimeter of the equilateral triangle. What does that mean if it's equilateral? Nora, could you take your earbuds out, please? What does it mean if the triangle is equilateral? All sides are congruent. All right, let's give these some letters, actually. Let's do A, B, C. So we know AB is congruent to BC, which is congruent to AC. Stay with me right now. I'm bringing you back. All right, isn't AC a chord in reference to the circle? Isn't BC a chord in reference to the circle? And isn't AB a chord in reference to the circle? Now, I have all three chords that are congruent. We learned a theorem that I'm leading you to. Do you guys see angles 1, angle 2, and angle 3? What are angle 1, angle 2, and angle 3 considered in reference to the circle? What kinds of angles? Angle 1, angle 2, and angle 3. AJ? Central angles. Didn't we learn a theorem saying if the chords are congruent, then the central angles are congruent? And if the central angles are congruent, what else are congruent? It was chords, central angles, and there was one more thing. Arcs, you got it. So right now I have the chords congruent, which means all these central angles are congruent, which means what? All of these arcs are congruent. So now I have a full 360-degree circle split into how many arcs? 3 congruent arcs. So I'm going to do 360 divided by 3, which is 120. That means arc AB is 120, arc BC is 120, and arc AC is 120. What do we know about the central angle and its arc? Central angle and its arc have to be the same. The central angle and its arc have to be the same. So what does that mean? Angle 1 is 120 degrees. Angle 2 is 120 degrees. And angle 3 is also 120 degrees. All right, so once you get the central angle, so first step, draw the radii to the corners. Draw the radii to the corners. Then divide 360 by however many central angles you have. Then what we're going to do is we're going to pick one of these triangles. It does not matter which triangle you choose. So I'm picking this triangle. And guess what I'm going to do in that triangle? I'm going to go ahead and I'm going to draw an altitude. And when I draw an altitude, it's going to bisect that side. You know, this is 8 and this is 8. What do you think happens to that 120 degrees when I draw that altitude? It splits into? Good. It splits into 2, 60 and 60. What kind of triangle am I dealing with? A 30, 60, 90. All right, so now I'm going to choose just one of these triangles. And we know across from the 30 is x. Across from the 60 is x root 3. Across from the 90 is 2x. My equation to solve for this is going to be 2x equals 8. So x will equal 4. That means my altitude is 4. And from A to the right angle, let's call this point D, A to D, is going to be 4 root 3. Now, if AD is 4 root 3, do we all agree that DB is also 4 root 3? So how long is AB? So if AD is 4 root 3 and DB is 4 root 3, AB is 8 root 3. This triangle is equilateral, right? Since all the sides are congruent, I can now find the perimeter. The perimeter is going to be 3 times 8 root 3, so the perimeter will be 24 root 3. I know this is different. We're going to do more. I'm going to come back and do number 3, but let's just sticking with the same process. Let's go to number 4 first. All right, a radius of a circle equals 6. Find the perimeter of the regular hexagon. Now, the word regular means equilateral and equiangular. So whenever you have a regular figure, that means all the sides are congruent and all the angles are congruent. That's what regular means, equilateral and equiangular. Again, so I have an equilateral, or I have a regular figure inscribed in a circle. We're going to go about this the same way we did the triangle. What was the first thing I told you to do in the triangle? The problem we just did. We got to draw in our radii. Lexi, where? We're going to draw in radii to the corners. And by us drawing in radii to the corners, I'm creating triangles. Doesn't it always come back to triangles at the end? No matter what we're doing, it always comes back to triangles. Now we know all of these radii are congruent, so they're all 6 units long. Okay, so now it says, again, remember, it said it was a regular hexagon. Because it's regular, doesn't that mean that all the sides are congruent? That's what regular means in all the angles. Well, Look at all the sides. Aren't they chords? Yeah, and if the chords are congruent, aren't the central angles congruent? So that means all of these central angles are congruent. And don't all these central angles create the full circle? Right? Because the arcs then are congruent, which means they create the full circle. So then how would I find just one central angle? If all those central angles are congruent, how would I find just one central angle? Joe, your back must be hurting. You've been holding up the class now for a while. If all those central angles are congruent, how would I find just one central angle? AJ?
180 or 360 divided by 6.
You got it, because remember, guys, if the central angles are congruent, then all these arcs are congruent. How many arcs? 6 arcs. And isn't a full circle 360 degrees? So what are we going to do? 360 divided by 6. So one central angle will equal 360 divided by the number of central angles. So in this scenario, it's going to be 360 divided by 6, which is 60 degrees. All right, at this point, what you're going to do, same thing we did with the triangle, is you're going to choose one of the triangles. Do you think it matters which triangle you choose? No. I'm going to choose this triangle. And in that triangle, I'm going to draw down an altitude. And when I draw that altitude, it's going to bisect the side. And what's it going to do to that 60 degrees? Split it. It's going to split it into 30 and 30. So now I'm going to choose just one of those yellow triangles. And I know opposite the 30 is x, opposite the 60 is x root 3, opposite the 90 is 2x. Am I going too fast? Okay. All right, so now what is my equation? My equation is going to be 2x equals 6, so x will equal 3. That means this bottom side is 3. So if half the bottom side is 3, what's the full side? 6. 3 and 3 makes 6. Now that I know one side of the hexagon is 6, do I have enough information to find the perimeter? Yeah, because it's equilateral. So the perimeter is going to be 6 times 6, which is 36. All right, let's go back. I just skipped one, right? Let's go back to number 3. Okay, so we can make this problem pretty simple if we want to. Or we can make it like more of a complicated problem. It says the diagonal of a square equals 4. So I'm going to go ahead and I'm going to draw the diagonal. And if you remember the properties of a square, you'll remember that what does a square, well, first of all, what are all the angles in a square? They are all 90 degrees. Right? And then I'm going to go ahead and I'm actually going to draw in my other diagonal. And then we can remember that what do the diagonals do to each other? The diagonals, anybody? They bisect each other. So if the diagonal is 4, then each part of them is 2 because the diagonals are congruent in a square. What do the diagonals do to the angles? What do the diagonals do to the angles? So remember, we know all the angles are 90. What does the diagonal do to the angles? If you remember the properties of a square, the diagonals bisect the angles. So this becomes 45, 45, 45, 45. There's one more thing to remember about the diagonals in a square. Not only do they bisect each other, but they are also perpendicular. So what are we dealing with? What kinds of triangles? 45, 45, 90, right? But there's a little bit of a problem. Why is there a little bit of a problem? It says find the radius of the circle. Are any of these segments in our triangle radii of the circle? No, because they're extending outside the circle, right? So I need to draw a radius. So what I'm going to do is I'm going to go ahead, I'm going to draw my radius. I'm going to take one triangle and I'm going to draw my radius down. Now, what happens when a radius touches a tangent? When a radius touches a tangent, you make right angles. So here are our right angles. So opposite the 90, okay. So now we have a 45, 45, 90, x, x root 2. I pulled out the triangle. My equation should be x root 2 equals 2. I'm now going to divide by root 2. And then rationalize. So we end up with 2 root 2 over 2. The 2's cancel. So x is equal to just root 2. So if this side is root 2, do we all agree this other side is also root 2? So what's the full... Oh, sorry. That's not what I'm not asking for the perimeter. What am I asking for? The radius. Isn't this the radius? That's root 2. So the radius equals root 2 units long. All right, I'm going to give you one to try on your own right now. Are we ready? So we don't have to worry about any of these other problems. I'm not going to worry about this. Not going to worry about this. Not going to worry about this. All right, you ready for me to give you a problem? Okay. Just going to look to see what I gave before. Okay, so I'm telling you we have an equilateral triangle inscribed in our circle. The radius of the circle is 12. I want you to find the perimeter of the triangle. So you're going to do this the same way we just did those other two problems before the last problem. Yes.
Can you scroll up to problem like 4 or 3 actually?
Are you good, Navia? All right, we only have a few minutes, so let me tell you what you should have done. To start off, you should have drawn your radii to the corners of the triangle. How many people did that? Excellent. They're telling us these radii are 12, 12, 12. All right, the next thing you have to do is find your central angles. Who remembers how to find the degree of the central angle? Lexi.
260 divided by 190.
Good. The angle is going to be 360 divided by the number of central angles. How many central angles do we have in this diagram? 3. So we're going to do our angle is equal to 360 divided by 3, which is 120. All right, at this point, you're going to choose one of the triangles. I'm choosing this one. And what are we going to draw in that triangle? What are we going to draw in that triangle? An altitude. And when I draw that altitude, it also bisects the side it connects to. So that 120 is going to get split into 60 and 60. So what are we dealing with? 30, 60, 90. All right, across from the 30 is x, across from the 60 is x root 3, across from the 90 is 2x. Our equation is going to be 2x equals 12, so x is equal to 6. Our altitude will be 6. The bottom side will be 6 root 3, so then the other bottom side is 6 root 3. So one whole side is not 6 root 3, it is 12 root 3. Do we now have enough to find the perimeter? Absolutely. The perimeter is going to be 3 times 12 root 3, which is 36 root 3. All right, we are done for today.